Hi, everyone. You're all very welcome to our webinar this evening. My name is Barry Mulvey. I'm chair of the Young Engineers Society and a committee member of the Electronic and Computing Division, both under Engineers Ireland. So this event has been organised by the Young Engineers Society in collaboration with the Electronic and Computing Division. And the event will be about digital twins. Their overview, their use cases, and their application. So we have two great speakers lined up for you tonight. We have Çagri Arican and Veronica Mariti Sesoko. And just a bit of housekeeping, we'll have a Q&A and panel discussion moderated by the Young Engineers Society Vice Chair, Shane O'Neill, after the speakers' presentations. So I'd encourage you all, if you have any questions, to please write them in the Q&A, and we will get around to them then. So at this point, I'd like to welcome our first speaker, Çagri Arican.
Thank you, Barry. Hello, everyone, and thank you for joining us this evening. Name is Çagri. I'm a data science manager in Applied Intelligence Ireland in Accenture. It's been 3 years so far here in Ireland with Accenture. Before that, actually, I have approximately 19 years of experience in the mostly digital twin area. Well, back in the day, we didn't call them digital twins, of course, but my specialty is on the optimization and simulation side of things. I'm an industrial engineer. So coming from an engineering background, I'm very happy to be a part of this community discussion this evening as well, and as part of the webinar. So I am mostly involved in the digital twins in my practice, and I'm trying to create more attention and grow this area in my practice as well, moving forward. So today I'm going to talk to you about the digital twins, about an overview about what they are, what value they bring into the table, and what are the couple of the use cases over here. And then I will be handing over to the Veronica, who will be sharing very interesting use cases with us as well. So first, let me start with a very, very high level. What is digital twin? So you probably heard the high level definition. It's just a virtual representation of a system or a process to enable data-driven decision-making. Well, you see, even hearing the definition doesn't help that much because it's a very broad definition. And if you have made a small research before this call, you might be able to see that there's lots of different types of digital twins. Yeah, I am not sharing my screen at the moment. I'm going to share in a couple of minutes. Just one thing before I share my screen on the high level side, each digital twin is built for a purpose. So I mentioned that they enable data-driven decision making. So because of that, actually, you cannot go ahead and, okay, I'm going to create a digital twin of this process or this machine or this equipment. You have to have some questions on your mind. You have to try to answer those questions, and this digital twin is purposed to answer those questions. So this is how they built initially. So let me start with the types of digital twins then before moving any further. And this is where I am going to share my screen. And give me 1 second. And hopefully you can see my screen right now.
Yeah.
Perfect. And let me maximize this as well. So yeah, I mentioned that about the multiple types of digital twins, and this is not an exhaustive list, to be honest, but I can say that there's 3 very high level types, very broad types. And first one is the product digital twin. This is a replica of an actual machinery, like a vehicle, such as a car or a jet engine. So these models enable us to assess the product life cycle management and do some stress tests within the product itself. And they mostly use real-time data, and sometimes they combine fluid dynamics for the airflow, like in the race cars, or for the jet engine as well. And they are also very, very good for the aftermarket maintenance planning as well. And the second type, the asset type of digital twins, are a replica of an equipment or process or a resource. And this can be a bioreactor in the pharmaceuticals or an electric motor. And one example over here is a predictive asset maintenance, for example. So how these models work is they get real-time information from all of these equipments, machinery, and they assess this information in real time to create insights. So in the predictive asset maintenance example, we, for example, try to predict some issues that might happen in the future before they happen. So we can get rid of some very, very costly maintenances, frequent maintenances, if it is not necessary, and we can identify potential issues even before they happen. Because sometimes what happens is, even you are maintaining your equipments frequently and properly, there can still be some issues between those maintenances, and these models can help you to capture them. And in some cases, like bioreactors, the machine itself might not be very, very expensive, but the product inside that equipment might be worth millions or millions of US dollars or euros. In bioreactor example, we are talking about biologics drug manufacturing, for example. The bioreactor is not that very expensive, though, but one batch of product inside a bioreactor can cost hundreds of millions of dollars. So if a failure in that simple machine, in that bioreactor, means that whole batch, means that hundreds of millions goes to waste. So that's why these models are pretty important. Then the next type is a process or system type of digital twin. These are a replica of a system or process or complex systems. This can be like manufacturing processes, a supply chain. So you see, a digital twin doesn't have to be always a replica of a physical equipment or a physical machine. So we can create a digital twin of a supply chain as well. And these models enable us to identify bottlenecks, visualize the wait times, queue lengths, and do some stress tests and capacity tests within the systems. Sometimes these systems doesn't exist. For example, for a new facility that we are planning to build, we can create a digital twin of the new facility even before it is built to see if it is going to run properly when it's built. And also similarly, when we are going to make some investments or some strategical changes on our systems, like in the supply chain case, if you would like to shut down a site globally or open up a new site in the other side of the globe, for example, how it's going to impact our inventories or such as those cases. So if we talk a bit further about this one, we talked about the digital twins that they are a virtual replica of the system or process. But how they work is they allow us to conduct experiments on the model of the system in compressed time, so that we can understand the behavior of the system and evaluate the various strategies to see the insights regarding the operation of the system in this virtual environment. So on the left-hand side, you will see a small diagram. What digital twins enable us is to just get rid of those costly real-life trials and errors. So that's what that red cross means in the middle, actually. So we take the current state from real life, we build an we create a replica of this current state, and we call this as-is model because it just reflects the real life system or process as it is right now. And after we make sure that it reflects the real life properly by doing some tests on historical data maybe, Then we move into the analysis phase, and we create different scenarios. We test out different alternatives, strategies, and this is where we come across what we call as to-be model, because this model now represents our future case, future state in the virtual environment. Once we are happy with this model, once we are happy with the results, then we can implement these into the real life, which we will call as the future state over here. So we can do all of these costly tests, experiments, trials and errors in the virtual environment. So this is one of the major benefits of the digital twins. And on the right-hand side, one thing I would like to mention is these digital twins mostly use real-life information. It can be historical data, but it can be real-time information as well, coming from sensors, from equipment, or sometimes some data is missing, and we capture that missing information by subject matter expert inputs. So that's offline data, nothing coming from real time, but we get that information anyhow. I'm going to mention about this, but this is one of the benefits of the digital twins. We don't rely actually on the availability of the data. We can capture some assumptions from the real life and use them, build our model on top of them as well. So because of that, digital twins mostly use statistical methods to capture these and sometimes variabilities, fluctuations in the real life as well. And the outputs of the digital twin can also be a kind of statistical output as well, showing us what might going to happen with what percentage, with what probability in the future. So moving forward, I mentioned about the fluctuations in the real life. Because one thing that digital twins also helps us identify is the wait times and queue lengths, which are not easily computable by by mathematical models actually. So we need a kind of a simulation methodology behind to capture this kind of dynamics. So for example, if we assume that in a banking environment, let's assume, if the average arrival time is 5 minutes, and if we do all of our calculations based on the static 5 minutes arrival time, inter-arrival time, we might be making some mistakes over there, because in real life, probably it might be in average 5 minutes, but it can be 3 minutes, 6 minutes, 7 minutes as well. And sometimes, you know, 2 customers arrive at the same time. So there hasn't been a rule in the real life that there will be exactly 5 minutes between each customer arrival. So this dynamic, unless you capture this one in your model, all of your results will be big assumptions, and you might make mistakes. So just to put this into life a little bit further is, on the top, actually, we are assuming that inter-arrival times are exactly 5 minutes, and down below, we are again using inter-arrival times of 5 minutes, but this time we are using statistical methods, both on the processing time and inter-arrival time. You see on the below, we sometimes have queues happening. Sometimes there are less people waiting. And at the right now, I think this animation is finished, but by the time of finished, we had 3 people already in the queue because of the varied processing time and varied arrival time. You see, this kind of dynamics is only be accessible by this kind of digital twins. Just a small example I want to show you over here. And before moving into a couple of examples, let me tell you about some high-level capabilities and benefits over here. I already mentioned you that digital twins shine where you have incomplete data. Because you can always use your subject matter expert information to complete that by statistical methods. And also, as I mentioned, it lets you to do what-if analysis on the virtual environment. So you can eliminate too risky or expensive or sometimes impossible live tests. In the case of, for example, a future facility that's going to be built, it's impossible to do live tests because you don't have that facility right now. Also, if your system is very large or complex, again, mathematical methods or optimization models sometimes cannot cover the dynamics of the real system. So you have to rely upon very heavy assumptions, and they might not be very accurate in that case. And as in our previous example of the interarrival times, if in real life the variability is important to you, like arrival times, processing times, or if you are creating a digital twin of a process like a supply chain, the demand might be variable. Your predictions into the future might include some variability. In this case, actually, digital twins are most effective compared to the other methods. And of course, it hasn't, digital twins doesn't have to include shiny animations, to be honest. So there's a misunderstanding that when we talk about digital twins, it always have to include those shiny 3D images over here. No, it doesn't have to. But if it does, it is very helpful to communicate ideas. It is very helpful to interact with stakeholders, to show them what's happening in the virtual environment. So let me continue on my presentation with a couple of examples. The first one that I'm going to mention to you this evening is the postal network digital twin that we were able to deliver for a European postal company. So this company was planning its 10-year horizon business strategy. But the challenge was because of the recent dynamics in the electronic commerce area, letter volumes are decreasing and parcel volumes are increasing. But this is a very old postal network, so all of their facilities and the network mostly focused around the letter deliveries. So because of this, their current network of processing sites and delivery offices is just every day becoming more and more increasingly unfit for this operation. So let me show you this on a small video over here. So this is an anonymous video we have created of this asset actually. This is a digital twin of this whole network where we were able to test out different scenarios on the whole postal delivery network and also the operational side of things within the processing facilities. So what you see on the screen is, of course, since this is anonymized version, because of the actually the non-disclosure agreements, I cannot show the real positions of these locations to you, but this is in a, let's say, hypothetical map. These are the locations within the whole country, the delivery locations, the processing center locations, and between each of these locations, the trucks are working. For example, this is a truck carrying 13 tons of equipment, 19 tons of mails, for example, between each of these facilities. This shows us one scenario of this whole distribution network, and we were able to test out different alternatives, different network models over here as well. If we focus on one particular processing plant, we can see the details of this processing plant. On the left-hand side, there are mails arriving. There are 4 types of mails, by the way. That can be a letter, a flat, a packet, or parcel. You can see from the labels that how many have arrived and how many are being processed over here. We'll go back a couple of seconds on the right-hand side over here. And in the middle, actually, we have both equipments, machines, I mean, and also manual resources down below as well. So we were able to see the equipment utilization. We were able to assess the equipment utilizations and idle times using this micro models over here as well. The 3D animation just helps us to see what's happening over here in real time, to be honest. This model works on the historical data that lets us to forecast what's going to happen within the next 10 years of time horizon. And from this processing facility, if you zoom out again, this is, let me pause here. This is again our network. And again, I have mentioned about this trucks working in between, but all of the satellite facilities over here are the distribution centers. So if you zoom into one of them, again, each one of these has the details of how many mails are collected and delivered from each one of these delivery centers. At this point, we might also focus on one of the equipments over here. This is one of the trucks that's moving in at the moment. And if you click on the details, for example, we can see what's the from location, what's the to location destination of this truck, and what's the type of truck, and what's the current travel time, vehicle capacity, and the utilization of the vehicle as well, and also what kind of mails it's currently carrying, how many letters or parcels, etc. So with this type of granularity, actually, the users will be able to come up with lots of different insights and various outputs as well, like this one. So this is on the map, actually shows us the utilizations of the facilities. So for each site, this is the heat map of the arrival times, for example. What's the service level within each of those locations? What's the utilization or idle times for each of them? If I move into further a little bit, this is a Sankey diagram which shows us the product field between the process centers and delivery facilities, or delivery offices actually. So it can be based on different products, different parcels, and it allows us to visualize what's the volume processed within each machine or resource over here. And then another type of output we can come across, we can create from this model is the equipment utilizations. And this allows us to visualize for example, the usage of the equipments and some bottlenecks over here as well. So this model actually enabled our client to be able to set their strategy for the next 10 years and come up with the optimal network decisions, optimal facility decisions on their network. So this is one example of the process digital twins. Next one, I'm just going to very briefly talk about this, conscious of the time. Let me switch to the next one. Yep, this is a cell therapy manufacturing digital twin. So cell therapy is a very specific type of production in the pharmaceutical industry. It actually starts from taking the blood cells from a cancer patient and modifies them, genetically modifies those cells, and then creates the drug product, and then returns back the modified product, or let's say the drug product, to the patient again. So this whole process end to end take approximately 21 days. And it's a very delicate process because there is absolutely no time and no error window for lateness, let's say, no time for delays allowed over here, because the customer in this case are patients and they are in their last stage of the cancer. So the product over here we are dealing is also live cells, not some machinery or steel equipment, let's say. Because of this is a very delicate process, and the processing times, variability, and everything in between needs to be simulated on a digital twin environment very thoroughly before making any changes or any decisions for the future. In this case, we were trying to ramp up the capacity of this whole manufacturing facility, let's say from 20 patients per week into the 25 or 30 patients per week. What bottlenecks we need to solve, how many resources we need and where, and what equipments we will need in the future. These kind of answers we try to answer with this model. And lastly, we already talked about capabilities and benefits, but again, just want to recap over here before handing it over to the Veronica. These models allows us to save time and save lots and lots of time actually on this design and experiment and strategy decisions. It lets us to visualize this complex dynamics. It creates a risk-free environment for us. And they let us to enable handle the uncertainty as well. So yeah, from this point forward, actually, I might hand it over to you, Veronica, and I'm looking forward to your presentation as well. It sounds very interesting.
Thank you so much, Çagri. So I'm gonna just do a quick introduction about myself. So I'm an engineer. I did my bachelor's in civil, then a master's in transportation. Just after, I just joined the council, so I was working in the local government here in Ireland. And yeah, it was very nice presentation about Çagri, and I really liked the level of detail you went to your use cases. I'm going to be talking a little bit more high level about digital twins. So I have started to look into that topic in 2019, basically when I started working. And since then, I just been like seeing how it's evolving, and it's really, really interesting. And one of the nice difference is going to be that my use cases are much more like at a neighborhood, region, city, or country level. So it's a little bit different, but I hope it gives a little bit of the flavor as well of what you can do and what's that about. So I'm just going to start sharing my screen. Hopefully that's going to work. Okay. So pretty much I'm going to try to cover it's about the journey of a digital twin. So it's about what is it, what is not, how we can start building one of those, and why should we be doing those kind of things, especially at a very, very high level. So if we just move here, I brought for you a little bit of a timeline. So just trying to be brief and very straightforward, let's say. So in 2019 was when I started working with digital twins, and at the time was also kind of like the start of people talking about this kind of concept. So was this buzzwords that the market was, okay, you should start investing in digital twin, that's going to change the future, and was a lot of excitement. And a lot of the companies, they wanted to get involved. Some of them, they were a little bit conscious. They thought it was just like a hype, and they couldn't really see how that would be helpful. There was a lot of kind of problems trying to understand what is digital twin. There was not a single definition. And I guess even nowadays, there is variations about those. But at the moment was at a city level, it was about 3D models and immersive technologies. It was about GIS, BIM, and just trying to understand how the digital twin was working in collaboration with all those other topics that we already knew before. So in 2020, I put here as like an exploratory phase, and that's one of the change that really enable us to move forward was the cloud-based platforms and the cloud power, because the data sets that I'm going to be talking about, it's really, really huge. It's very big data, and you have to do like processing. And at the time in 2019, when we were using the 3D models at a city level, we needed a gaming kind of computer specifications were very, very high. So it wasn't accessible to everyone. And when we moved to the cloud, we could do much more, and it was quicker, and you could just live there and get everything being done while you were working on other things as well. So we started exploring some of the use cases, different platforms. We engaged with loads of different platforms, try to understand what was the difference between them, what was the benefits, what are the challenges. And the industry was very much in early days, engaging with cities. So we were working in partnership with private sector and with academia to try to co-develop the use cases and the requirements. And in 2021, we had our biggest phase of challenge. And that's because we were really hands-on trying to deliver those use cases. It wasn't anymore about just talking and trying to see what's the potential. It was actually, okay, so let's go and do it. I want to see how that works. We had to choose partners, find objectives, and we did a lot of knowledge sharing with other cities and other partners. In 2022, it was the actual delivery of most of proof of concept, and that's still going on in 2023, and I foresee to still keep going until 2025 and so on. But in 2022, it was very ad hoc engagements. It was still working a lot with stakeholders to get their buy-in. The market was also trying to develop their tools and customize to our use cases. And for us, the main goal was to prove the value of those use cases that we identified before. And for this year, it's very much what I see. It's maturing and it's starting to get some shape. So that's when we actually have a program in place. And basically, we're going to be delivering under 5 pillars. I'm going to try to talk about 2 of the use cases in a little bit more detail, but still very briefly, because they are huge projects. So jumping. So at the start, like I mentioned, for us was okay. So digital twin, is it about 3D models? Because that's pretty much how we were presented. At a city level, they were telling us, oh, we can just build the whole city in a 3D model, and that's going to be a virtual environment. You can experiment using AR, VR, and we were like, okay, so let's do it. So there was a lot of potential. We decided to commission a 3D model of a small area of Dublin, and then we were testing different levels of detail. So sometimes you could bring from BIM models with all the information, the materials. Sometimes you were just going to do volumetric kind of blocks, and we were just testing to see how the technology works. And we got pretty much very good use cases to present to people and just to showcase technology and potential. Some of the other layers that we at the start were a little bit also unsure was about GIS and BIM, or building information modeling. So we were kind of, okay, so digital twin is a 3D model with GIS. That's what was in our minds. And pretty much it is, but you can even keep adding more and more layers, and that's where we see the value. So the GIS was one of the components to make our digital twin be more beneficial and deliver some actual impact to the city, while the BIM, or the building information modeling, it's also, I would say, a mini digital twin, and usually it's done at a building level where they have all the different components. So the design, the architecture, the structures, all the sensors to keep doing maintenance and predictions. But in our case, the BIM, we would use more just the architecture shape and to build and fit into our 3D model of the city. So some of the questions were how we can clean up those data, because it was so heavy already being BIM, because it has all the information about the building. And at city level, we don't need that. So that was one of our challenges, how to bring all of those together and actually deliver something impactful for the city while you're still managing the amount of data, the costs, and all of those, because hosting a big BIM model, it's very, very heavy. Imagine if you have like a city with thousands and hundreds of buildings. It was just impossible. You couldn't even move. So to summarize, after doing all those studies, trying to understand GIS, BIM, 3D models, we kind of came up with a definition that was that digital twin is basically anything that can be replicated the real environment into digital version. And it's not just about 3D models or GIS or BIM. It's much more than that, because each of those are just one layer of our components. And the real value of this is to visualize those different layers of information together. It's about when you combine all of those, seeing and understand the interactions and the codependencies of them, so you can get new insights. Then, for example, if you're looking into a council, many times you are working in silos, so the planning departments might not work as close to the transportation or as close to the air quality. Of course, they have like some interactions, but you don't have all this information in the same place. So you kind of miss opportunities to see how they interact to each other and how they're gonna impact between each other. That's the value of a digital city scale, and I guess even like in a building or other use cases. It's also about the better engagement with non-technical audience, and I think Çagri brought some very good examples on how we can better visualize and understand quicker, because sometimes an image or a video, it's much easier to explain than just text or trying to show 2D plans and stuff. And then the last one was the management and data governance tool. So it's about, again, like all the information in a single place, so centralizing a single source of truth. And then at the end, what I really wanted to bring was that it is still evolving and it's expanding, especially at the city level. And some of the countries in Europe, they are starting to study at a country level. What I see is not just the scale, but it's about how we can evolve from using historical data into actually using a real-time data on how the things are working now. And then from combining all those two, we can start doing the prediction. So on the example from Çagri, he really mentioned some nice use cases of how you can do those. But at city level, we are still trying to work on historical data that is massive, but it's maybe not standardized or easy to access, and then how we can better then collect real-time data and start building a baseline. And then when you combine those two, is when we can start doing predictions. So just summarize, what is the flow for a city scale kind of digital twin? So we have the data collection that could be just LiDAR or photogrammetry of the city. And then with those informations, you can build a 3D reality mesh or 3D model. And then when you combine with BIM, assets, GIS information, it's when you start building your digital twin at a city level. But just that, it has some benefits, of course, but the other benefits that you can add on is when you start doing the AI, machine learning, and all of those to actually be able to analyze all those big sets of layers together and get some insights or try to understand the relationships and how you can keep updated as well. So that's pretty much what we can get as an output. So it can be informing our stakeholders in the form of a dashboard. It can be a virtual reality application where people can better interact with the city. It can be an AR application as well that I'm going to show a little bit what you can do. And then you can do many other things using interoperability and working with different companies and different use cases. It's going to depend. But if you can do building in a way that is interoperable, that's the best, because you can get most of the benefits. So a little bit focusing now on the components of each of those. So I would say if you're trying to establish a program of digital twin, you really need to understand what are the activities or the use cases that you're going to be focusing on In our case, it's really high level. It's those like 5 pillars that I was mentioning before. And then you have to choose your tools or technologies, and in each of these stages, so how you're going to capture your data, how you're going to process, what kind of analysis you want to do, what are the layers, and how you're going to do the integration of those layers. And then at the end, on the top, that's the output. So it's going to be VR, AR, or mixed reality application. It's going to be just a web-based kind of application that people are going to interact with. It's going to be a dashboard. So you just need to think about those, and those are going to also orientate you about how you're going to move forward and your requirements and your partners and all of those. So moving now into a little bit of the timeline and evolution of digital twin and trying to bring some of the use cases to you. I have a very short video that unfortunately we don't have time to see all the videos, but this is the 3D model that we brought together, and basically what we did was we had all those buildings, so we scanned the city, we built a 3D model of as is, and then we insert this architecture project that was the whitewater rafting project. And it's a very complex one. So before, during the planning application process, what we used to do is show everything in 2D, and it was very hard for people to understand. And in this way, we brought the virtual reality so people could experiment how was the space. And we start seeing that people could provide us with better feedback. And the way that we got there was using a hackathon. So we just open up different data sets, the 3D model that we had, and we just asked people, please come together, let me know what you can do. And then the other application is the Dublin Fire Brigade, and that's about using AR application to visualize the main features of a building. So the fire alarm panel, the hydrants, and all of those. And that's one of the other projects I'm going to mention further. So from that project that I was showing before, what we evolved was when we got access to the cloud or web-based solutions. And that's because they have so much more power. And we were in the middle of the pandemic, so we had to move into an online version where everyone could access and interact with us and provide feedback in an online platform. And it couldn't use a very expensive laptop to do VR. So what we did was really to engage with this different provider, and we start testing how we could make a web browser and even a mobile version of that. So the second use case that I want to bring to you, and that's one of my favorite ones, it's about emergency service, and it's all about how we can build those 3D models of high-risk buildings. So this one that is in the video, it's about a chemical plant. And what you could do was actually bring together all the different layers of information that they had access. So that would be the weather, the location, the time, the occupancy of the buildings, the height of those buildings, what are the street conditions, the construction, exposures, appliance, and you could start tagging. Even they were able to connect with the database of the company to know what was the chemical stored in each of the reservoirs. So in case of a fire, they are well able to know, okay, so this one is very inflammable. So that's our priority. We cannot let the fire get to here. Or with the weather, they could also start seeing what's the direction of the smokes and start sending alerts for people to close their windows. So it's a very nice kind of application. And as I was mentioning, we had loads of different use cases, and I can't really detail in this talk because we have a time constraint. I wanted to bring a little bit of those like 5 pillars that I was mentioning before. That I kind of broke into 6, and that's because the first one is R&D. So that's very much academic, and a lot of the private sector. They're investing in data analytics, in AI, machine learning, AR, VR, sensors, get data in real time, and just trying to deliver what are the use cases. One of them is, and it's big, is the asset management and inventory. So how we can do automation of data collection and classification, how we can use the real-time and prediction monitoring. So this one that I brought for you is one of the projects that we did together with Minute, and we're kind of just using Google Street View data to be able to identify and geolocate every traffic light and drainage of the city, and then they could build an asset management and inventory. The second one was the emergency service, so that's pretty much what I was explaining in the slide before. The third one is the climate change and sustainability. So one of the very nice use cases that is not from Dublin, that's from Berlin, that I came across was combining the data sets of air quality. So we would have real-time information of air pollution. And then you could put your headset on and you actually could see all the pollution out there. And that was a way of trying to bring consciousness for people, because usually if you don't see, you don't care. So that was a way of trying to make people be more conscious and pay more attention about air quality in your neighborhoods. I also brought for you a little bit of that real-time information that was being used in construction at the moment. So how you can use those robots to do LiDAR scans during the construction, and you can see and track the development of your building, and you have a very accurate 3D model at the end of your construction. What are the pipes, ducts, and everything else. The other one, it's about the planning application and consultation that I was also showing case before. And the last one, it's about tourism and culture or arts. And that's pretty much where you use AR and VR, and you can do storytelling about different sites, showcase how was the site, the heritage site many years ago, and just trying to bring together some different layers as well of digital twin. So just to try to keep a little bit on time for Q&A, we have different stakeholder groups, and in my case was the quadruple helix, so academia, government, industry, and community, and each of those participates in different ways. They can either be developing the platforms, doing the analysis, or developing the tools to do the analysis, or they can actually be the use case or the people that are going to get the benefits at the end of the digital twin. So to conclude, I just brought some learnings. So during this journey of the buzzwords to establishing a digital twin program, we learned that it is not yet a platform that fits all. As you could see, a digital twin can be many different things and many different use cases and cutting across everything else. So we don't have a single platform for digital twin. The technology is evolving and it's maturing as we speak. So I'm sure we're gonna see loads of many different use cases and potential of things that we can't do today, but tomorrow maybe. And then the different aspects for the city level, we have the BIM, GIS, 3D models, the immersive technologies, and all the different data sets that we can have. The multiple potential benefits across all the areas is going to depend on the different levels of maturity and adoption. So when we talk with different cities, we can see that each of them, they are in different stage of the journey and they are taking their own path. But at the end of the day, everything is aligned. So we are evolving and going in the same direction. And then some of the questions that we had as well was the business model. So how to make it sustainable, how you're going to be able to make money, the companies, or to pay for those service. And those are still like questions that the business are trying to figure out. And then on our side and everyone's side is about data challenge. I think that's still the main barrier. It's about the quality of the data, how you're going to do the collection, the processing, the standards, interoperability, data management, storage, and governance. Those are still the main big questions that are being asked and are being kind of the blocker to keep evolving the digital twin in a more fast-paced way. So I hope that inspire you a little bit about the future, and I'm going to hand over to Shane for Q&A.